Okay, let's dive into this explainer. Welcome back, everyone. Today, we're cutting through all the buzzwords to look at a very concrete, highly structured blueprint. We're talking about what makes a truly world-class, intelligent apparel manufacturing facility. Now, if you follow the industry, you've definitely heard the term smart factory tossed around a lot. But today, our goal is to really demystify that concept. We're going to break down the exact anatomical structure of a smart factory into an actionable blueprint.
Right off the bat, I want to challenge a pretty common assumption. A modern smart factory doesn't actually make clothes. I know, sounds a bit crazy, right? But at its core, physical manufacturing is no longer the main gig. Instead, a world-class intelligent factory calculates data. The actual physical assembly of a garment, well, that's just the final, almost inevitable outcome of literally billions of upstream data calculations.
To really wrap our heads around this, we have to contrast the old way of doing things with this new reality. The traditional approach was basically reactive physical labor. Make the garment, and then check to see if it's right. But the intelligent approach is fundamentally predictive. You calculate the garment, and then you perfectly execute it. It's about shifting the entire heavy lifting of manufacturing from the physical floor straight into the digital realm, way before a single thread is ever cut.
What's absolutely fascinating is how a digital command center maps out a living factory ecosystem. You have a completely integrated environment where every single machine, every piece of fabric, and every worker is connected through a centralized brain. It's literally an organism, and it's driven entirely by real-time data monitoring and intelligent decision-making, which ensures a continuous flow with basically zero bottlenecks. So here's our roadmap for today. We're going to cover the smart factory anatomy, the brain, the heartbeat, the immune system, the data bloodline, and finally, where we're headed in the next 5 years. Starting with Part 1, the smart factory anatomy. A true world-class factory relies on a very specific non-linear architecture of value stream, data flow, and control flow. Honestly, think of it exactly like a human body. The digital engineering department, that's the brain, making all the upfront decisions. The manufacturing execution system, or MES, is the central nervous system relaying signals. The physical equipment on the floor is just the muscle. And data? Well, data is the blood pumping through the entire facility, keeping the whole shebang alive and moving.
Moving on to Part 2, brain, engineering and materials. Let's see how this builds.
The true frontier of intelligent manufacturing is digital engineering. Because before anything is physical, it has to be digital. We're talking about 3D virtual sampling and AI-driven process design. The AI actively breaks down standard operating procedures, estimates the standard minute value, or SMV, for every single task, and maps out the entire production route. It's kind of like a GPS calculating the absolute perfect route for your thread before you even turn the key in the ignition. The garment is completely calculated, simulated, and optimized in a virtual space before it ever hits the floor. And the leap in capabilities here is staggering. While traditional engineering relied on manual time studies and, a lot of trial and error, AI engineering analyzes tasks instantly. It predicts exact production times, automatically flags which specific operations are ripe for automation, and even generates machine programs without human intervention. It drastically reduces the reliance on individual engineer experience, meaning you get standardized excellence across the board, every single time. Now, directly connected to that brain is the factory's digestive tract, the material intelligence system. We're not talking about a dark, dusty warehouse here. It's a dynamic ecosystem that uses AI forecasting to anticipate demand and automated robotics to retrieve materials. The crucial takeaway here is that the quality and status of the incoming materials dynamically dictate the production path. If a fabric roll has even a slight variance, the AI knows instantly, and it adjusts the downstream machine parameters automatically. Which brings us to Part 3, heartbeat, cutting and manufacturing. Let's head to the physical execution floor. The cutting room is the pacing control center for the entire operation. It flows through 4 incredibly intelligent steps. First, AI marker making optimizes fabric utilization down to the millimeter. Second, automatic spreading ensures perfect tension. Third, high-speed CNC or laser cutting executes the pattern. And finally, automated bundle management tags every single piece with a digital ID. This dictates the rhythm, the actual heartbeat for absolutely everything that follows. There is a direct relationship between the physical muscle of the factory and the digital data orchestrating it. Data actively drives these physical machines.
For instance, in complex waterproof bonding, smart sensors continuously monitor temperature and pressure. They adjust in real time to eliminate bottlenecks and ensure perfect execution. It's a real game changer.
On to part 4, immune system, quality control. In a true quality command center, high-precision AI visual inspection cameras are constantly monitoring stitching, fabric integrity, and component alignment in real time. This functions exactly like an active immune response in the body. When an anomaly is detected, it doesn't just flag a defective garment, it actually sends data back to the offending machine to correct the parameter immediately. It creates a completely closed-loop control system. Now, I want you to pause for a second and imagine something pretty radical. What if your factory floor didn't have a dedicated quality control department at the end of the line? What if that entire concept was just obsolete? Well, the crucial point is exactly this idea. In the future, quality is predicted, not inspected. By utilizing real-time data, AI models analyze machine vibrations, material tension, environmental factors, you name it, to predict and prevent a defect before the needle ever pierces the fabric. We are shifting away from just catching mistakes to engineering an environment where mistakes mathematically cannot happen.
Now for part 5, the data bloodline. Let's see how this all moves. In a smart logistics system, you'll find a total lack of manual pallet jacks or chaotic aisles. Intelligent material flow routes semi-finished and finished goods using automated handling robots, or AMRs, and conveyor networks. Every single item has its own digital identity, flowing seamlessly through smart sorting and automated packing toward multi-channel delivery, entirely without human intervention. The bloodline is fast, transparent, and absolutely automated. Finally, part 6, the next 5 years. The ultimate destination we're heading toward is the digital twin. We are building a one-to-one virtual replica of the entire factory. Think about it. Before you launch a new product line or rearrange your floor space, you will run thousands of simulations in the digital twin. You'll identify bottlenecks, optimize your energy usage, and balance your production lines virtually. This guarantees maximum efficiency long before anything hits the real-world floor. No way around it, this is for sure the future. Over the next 5 years, 5 technological leaps are going to totally redefine our capabilities. 1. AI engineering systems will auto-generate production routes. 2. Quality prediction will completely replace manual inspection. 3. Equipment will become thinking assets, adjusting on the fly. 4. Human-machine collaboration will empower workers with incredibly smart tools. And 5. Digital twins will serve as our virtual testing grounds for absolute perfection. And this brings us right back to our ultimate vision. Remember what we said at the beginning? A smart factory isn't achieved just by buying a bunch of expensive robots and tossing them into a room. True world-class manufacturing is about seamless, data-driven harmony. It's about building a living, breathing digital organism where data flows freely, empowering both human operators and automated machinery to perform at unprecedented levels. I want to leave you with a provocative thought as we wrap up this explainer. Look closely at your own operations. How does your supply chain measure up to this digital reality? Are you still making things and then checking them? Or are you ready to calculate, predict, and execute with absolute precision? It's a fascinating shift, and the time to adapt is right now. Thanks so much for joining me on this deep dive, and keep learning.